Hello and welcome to the introductory video of Data Science with Python course offered by Simplilearn. In this video, we'll go over some interesting information about data science and Python. Have you ever been asked by your stakeholder who your existing customers are, and how do you retain them in this competitive market? Or how do you find new business opportunities? How do you analyze the existing and historical data to offer some new line of data-driven products and services? Or build a system which is highly available and scalable by analyzing the server logs and understanding the issue patterns? Well, data science is the answer for all such questions. Data science is a new, powerful approach and a discipline which combines aspects of statistics, mathematics, programming, and visual techniques to turn data into information in semi or fully automated fashion. Data scientists are highly in demand and valued. And as a data scientist, it will be your job to analyze the data and offer solutions and ideas for improvement in organizations. Doesn't it sound exciting? Python is one of the most widely used technologies in this domain. It has an extensive library with built-in modules, providing easy access to system functionalities, which not only improves accessibility, but also provides standardized solutions for everyday programming challenges. Apart from being an open-source ecosystem, Python and most of its incredible libraries are platform independent. Python is part of the winning formula for productivity, software quality, and maintainability for many companies, and because of its flat learning curve, it's one of the leading technologies used globally. So how does the future look for Python as a tool for data science? According to KD Nuggets, 46% of the data science jobs list Python as a required skill, second only to SQL. According to a survey by the Association for Computing Machinery, or ACM, posted on javaworld.com, Python has surpassed Java as the top language used to introduce U.S. students to programming and computer science. The Defense Advanced Research Projects Agency recently awarded $3 million to develop data analytics and data processing libraries for Python. McKinsey & Company, a trusted advisor and counselor for many of the world's most influential businesses and institutions, projects that by 2018, the demand for data scientists who know Python may surpass supply by perhaps 60%, making Python a must-know skill for data scientists. Forbes.com mentions that the demand for Python programmers in big data-related positions increased by 96.9% in the last 12 months. Learning data science was never this much fun. Before diving into the course details, let's get a glimpse into our exciting range of learning modules. Delve into Python. Play with Python. Learn the Python way. Be the Python coder. Simplilearn's Data Science with Python course comprises 40 hours of instructor-led training, 24 hours of e-learning, 4 real-life industry projects, assignments, and 3 question sets comprising 50 questions each. To get certified in data science with Python, you'll need to complete any one project and get them evaluated by the lead trainer. Score at least 80% on the online exam. Teaching assistant support from the Simplilearn staff anytime during the course and for projects. Queries can also be submitted at help and support on www.simplilearn.com or get connected with the staff on SimpliTalk and live chat options. Prerequisite for this course is a fundamental knowledge of Python. Don't have it? Don't worry. Subscribe to Simplilearn's Python for Beginners course for free. And that's about it. Go ahead and begin Data Science with Python course and get started with the first lesson, Data Science Overview. Happy learning! Hi, I am your host and guide for this course on data science with Python offered by Simplilearn. I will take you through this lesson that gives an overview of data science. Through this lesson, you will get to know what data science is and the skills you need as a data scientist. This will help you discuss clearly your roles and responsibilities as a data scientist and look at various applications of data science. You will also learn how data science works with big data to extract useful information, explore data science as a discipline, and understand how it's shaping the world. This lesson will throw light on the importance of data science. The lesson will help you learn and understand Python, a popular programming language used by data scientists, the problems it resolves, and how it's an effective and user-friendly data science tool. What is data science? Let's start with some of the common definitions that's doing the rounds. Some say that data science is a powerful new approach for making discoveries from data. Others term it as an automated way to analyze enormous amounts of data and extract information from it. Still others refer to it as a new discipline which combines aspects of statistics, mathematics, programming, and visualization to gain insights. Now that you have looked at some of its definitions, let's learn more about data science. When domain expertise and scientific methods are combined with technology, we get data science, which enables one to find solutions for existing problems. Let's look at each of the components of data science separately. The first component is domain expertise and scientific methods. Data scientists should also be domain experts, as they need to have a passion for data and discover the right patterns in them. Traditionally, domain experts, like scientists and statisticians, collected and analyzed the data in a laboratory setup or a controlled environment. The data was then subject to relevant laws or mathematical and statistical models to analyze the dataset and derive relevant information from it. For instance, they used the models to calculate the mean, median, mode, standard deviation, and so on of a dataset. It helped them test their hypothesis or create a new one. In the next slide, we will see how data science technology has now made this process faster and more efficient. But before we do that, let's understand the different types of data analysis, an important aspect of data science. Data analysis can either be descriptive, where one studies a dataset to explain what happened, or be predictive, where one creates a model based on existing information to predict the outcome and behavior. It can also be prescriptive, where one suggests the action to be taken in a given situation using the collected information. We now have access to tools and techniques that process data and extract the information we need. For instance, there are data processing tools for data wrangling. We have new and flexible programming languages that are more efficient and easier to use. With the creation of operating systems that support multiple OS platforms, it's now easier to integrate systems and process big data. Application designs and extensive software libraries help develop more robust, scalable, and data-driven applications. Data scientists use these technologies to build data models and run them in an automated fashion to predict the outcome efficiently. This is called machine learning, which helps provide insights into the underlying data. They can also use data science technology to manipulate data, extract information from it, and use it to build tools, applications, and services. But technological skills and domain expertise alone, without the right mathematical and statistical knowledge, might lead data scientists to find incorrect patterns and convey the wrong information. Now that you have learned what data science is, it will be easier to understand what a data scientist does. Data scientists start with a question or a business problem. Then they use data acquisition to collect data sets from the real world. The process of data wrangling is implemented with data tools and modern technologies that include data cleansing, data manipulation, data discovery, and data pattern identification. The next step is to create and train models for machine learning. They then design mathematical or statistical models. After designing a data model, it's represented using data visualization techniques. The next task is to prepare a data report. After the report is prepared, they finally create data products and services. Let us now look at the various skills a data scientist should have. Data scientists should ask the right questions for which they need domain expertise, the curiosity to learn and create concepts, and the ability to communicate questions effectively to domain experts. Data scientists should think analytically to understand the hidden patterns in a data structure. They should wrangle the data by removing redundant and irrelevant data collected from various sources. Statistical thinking and the ability to apply mathematical methods are important traits for a data scientist. Data should be visualized with graphics and proper storytelling to summarize and communicate the analytical results to the audience. To get these skills, they should follow a distinct roadmap. It's important they adopt the required tools and techniques like Python and its libraries. They should build projects using real-world datasets that include data.gov, NYC Open Data, Gapminder, and so on. They should also build data-driven applications for digital services and data products. Scientists work with different types of datasets for various purposes. Now that big data is generated every second through different media, the role of data science has become more important. So you need to know what big data is and how you are connected to it to figure out a way to make it work for you. Every time you record your heartbeat through your phone's biometric sensors, post or tweet on the social network, create any blog or website, switch on your phone's GPS network, upload or view an image, video, or audio. In fact, every time you log into the internet, you are generating data about yourself, your preferences, and your lifestyle. Big data is a collection of these and a lot more data that the world is constantly creating. In this age of the Internet of Things, or IoT, big data is a reality and a need. Big data is usually referenced by 3 V's: volume, velocity, and variety. Volume refers to the enormous amount of data generated from various sources. Big data is also characterized by velocity. Huge amounts of data flow at a tremendous speed from different devices, sensors, and applications. To deal with it, an efficient and timely data processing is required. Variety is the 3rd V of big data because big data can be categorized into different formats, like structured, semi-structured, and unstructured. Structured data is usually referenced to as RDBMS data, which can be stored and retrieved easily through SQLs. Semi-structured data are usually in the form of files like XML, JSON documents, and NoSQL database. Text files, images, videos, or multimedia content are examples of unstructured data. In short, big data is a very large information database usually stored on distributed systems or machines popularly referred to as Hadoop clusters. But to be able to use this database, we have to find a way to extract the right information and data patterns from it. That's where data science comes in. Data science helps to build information-driven enterprises. Let's go on to see the applications of data science in different sectors. Social network platforms such as Google, Yahoo, Facebook, and so on collect a lot of data every day, which is why they have some of the most advanced data centers spread across the world. Having data centers all over the world, and not just in the US, help these companies serve their international customers better and faster without any network latency. They also help them deal effectively with the enormous amount of data. So what do all these different sectors do with all this big data? Their team of data scientists analyze all the raw data with the help of modern algorithms and data models to turn it into information. They then use this information to build digital services, data products, and information-driven apps. Now let's see how these products and services work. We'll first look at LinkedIn. Let's suppose that you are a data scientist based in New York City. So it's quite likely that you would want to join a group or build connections with people related to data science in New York City. Now, what LinkedIn does with the help of data science is that it looks at your profile, your posts and likes, the city you are from, the people you are connected to, and the groups you belong to. Then it matches all that information with its own database to provide you with information that is most relevant to you. This information could be in the form of news updates that you might be interested in, industry connections, or professional groups that you might want to get in touch with, or even job postings related to your field and designation. These are all examples of data services. Let's now look at something that we use every day: Google's search engine. Google's search engine has the most unique search algorithm, which allows machine learning models to provide relevant search recommendations, even as the user types in his or her query. This feature is called autocomplete. It is an excellent example of how powerful machine learning can be. There are several factors that influence this feature. The first one is query volume. Google's algorithms identify unique and verifiable users that search for any particular keyword on the web. Based on that, it builds a query volume. For instance, Republican debate 2016, Ebola threat, CDC or the Center of Disease Control, and so on are some of the most common user queries. Another important factor is the geographical location. The algorithms tag a query with the locations from where it is generated. This makes a query volume location specific. It's a very important feature because this allows Google to provide relevant search recommendations to its user based on his or her location. And then, of course, the algorithms consider the actual keywords and phrases that the user types in. It takes up those words and crawls the web looking for similar instances. The algorithms also try to filter or scrub out inappropriate content. For instance, sexual, violent, or terrorism-related content, hate speeches, and legal cases are scrubbed out from the search recommendations. But how does data science help you? Today, even the healthcare industry is beginning to tap into the various applications of data science. To understand this, let's look at wearable devices. These devices have biometric sensors and a built-in processor to gather data from your body when you are wearing them. They transmit this data to the big data analytics platform via the IoT gateway. Ideally, the platform collects hundreds of thousands of data points, and the collected data is ingested into the system for further processing. The big data analytics platform applies data models created by data scientists and extracts the information that is relevant to you. It sends the information to the engagement dashboard, where you can see how many steps you walked, what your heart rate is over a period of time, how good your sleep was, how much calories you burned, and so on. Knowing such details would help you to set personal goals for a healthy lifestyle and reduce overall healthcare and insurance costs. It would also help your doctor record your vitals and diagnose any issue. The finance sector can easily use data science to help it function more efficiently. Suppose a person applies for a loan. The loan manager submits the application to the enterprise infrastructure for processing. The analytics platform applies data models and algorithms and creates an engagement dashboard for the loan manager. The dashboard would show the applicant's credit report, credit history, amount if approved, and risks associated with him or her. The loan manager can now easily take a look at all the relevant information and decide whether the loan can be approved or not. Governments across different countries are gradually sharing large datasets from various domains with the public. This kind of transparency makes the government seem more trustworthy. It provides the country data that can be used to prepare itself for different types of issues, like climate change and disease control. It also helps encourage people to create their own digital products and services. The U.S. government hosts and maintains data.gov, a website that offers information about the federal government. It provides access to over 195,000 datasets across different sectors. The U.S. government has kicked off a number of strategic initiatives in the field of data science that includes U.S. digital service and open data. We have seen how data science can be applied across different sectors. Let's now take a look at the various challenges that a data scientist faces in the real world while dealing with data sets. Data quality. The quality of data is mostly not up to the set standards. You will usually come across data that is inconsistent, inaccurate, incomplete, not in the desirable format, and with anomalies. Integration. Data integration with several enterprise applications and systems is a complex and painstaking task. Unified platform. Data is distributed to Hadoop Distributed File System, or HDFS, from various sources to ingest, process, analyze, and visualize huge datasets. The size of these Hadoop clusters can vary from few nodes to 1,000 nodes. The challenge is to perform analytics on these large datasets efficiently and effectively. This is where Python comes into play with its powerful set of libraries, functions, modules, packages, and extensions. Python can efficiently tackle each stage of data analytics that includes data acquisition. Python libraries such as Scrappy comes handy here. Data wrangling. Python data frames are very efficient in handling large datasets and makes data wrangling easier with its powerful functions. Explore. Matplotlib libraries are very rich when it comes to data exploration. Model. Scikit learns statistical and mathematical functions to help to build models for machine learning. Visualization. Modern libraries such as Bokeh creates very intuitive and interactive visualization. Its huge set of libraries and functions make big data analytics seem easy and hence solves the bigger problem. Python applications and programs are portable and helps them scale out on any big data platform. Python is an open-source programming language that lets you work quickly and integrate systems more effectively. Now that we have talked about how the Python libraries help the different stages of data analytics, let's take a closer look at these libraries and how they support different aspects of data science. NumPy, or numerical Python, is the fundamental package for scientific computing. SciPy is the core of scientific computing libraries and provides many user-friendly and efficiently designed numerical routines. Matplotlib is a Python 2D plotting library which produces publication-quality figures in a variety of hard copy formats and interactive environments across platforms. Scikit-learn is built on NumPy, SciPy, and Matplotlib for data mining and data analysis. Pandas is a library providing high-performance, easy-to-use data structures and data analysis tools for Python. All these libraries, modules, and packages are open source, and hence using them is convenient and easy. There are numerous factors which positions Python well and makes it the tool for data science. Python is easy to learn. It's a general-purpose, function, and object-oriented programming language. As Python is an open-source programming language, it is readily available, easy to install, and get started. It also has a large presence of open-source community for software development and support. Python and its tools enjoy multi-platform support. Applications developed with PyCon integrate easily with other enterprise systems and applications. There are a lot of tools, platforms, and products in the market from different vendors, as they offer great support and services. Python and its libraries create unique combinations for data science. Because of all these benefits, it's usually popular among academicians, mathematicians, statisticians, and technologists. Python is supported by well-established data platforms and processing frameworks that help it analyze data in a simple and efficient way. Enterprise Big Data Platform. Cloudera is the pioneer in providing enterprise-ready Hadoop Big Data Platform and supports Python. Hortonworks is another Hadoop Big Data Platform provider and supports Python. MapReduce, MapR is also committed to Python and provides the Hadoop Big Data Platform. Big Data Processing Framework. MapReduce, Spark, and Flink provides very robust and unique data processing framework and support Python. Java, Scala, and Python languages are used for big data processing framework. Let us now quickly recap what we have learned in the lesson. Data science is a discipline which combines aspects of statistics, mathematics, programming, and domain expertise. Data scientists are solving bigger problems in public and private sectors. There are a lot of data sets available for free to apply data science and turn them into data services and data products. Data scientists are more in demand with the evolution of big data and fast real-time analytics. Python is a powerful language and a preferred tool for data science. This concludes the lesson on data science overview. In the next lesson, we will discuss data analytics.